Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face Trending List, published on September 13th, 2025, just 3 days ago. The headline is a massive, simulatable indoor dataset of about 40,000 scenes that actually keeps the tiny objects, delivering realistic clutter and physics-consistent layouts. The paper is titled InternScenes, a large-scale simulatable indoor scene dataset with realistic layouts, and the implications for model training are quite significant. Beyond scale, the work integrates real scans, procedural and designer scenes, adds interactive objects, resolves collisions with physics, and demonstrates tougher benchmarks for scene generation and navigation. Also, the authors shared a GitHub repo. You will find the dataset structure and sample layouts, a real 2Sim pipeline, installation and Isaac Sim setup, requirements, tutorials for visualization and usage, sample data, rendering scripts, and semantic layout formats. The README highlights scale, interactivity, tasks supported, and a TODO roadmap. Well, Figure 1 presents the whole offering at a glance, showing that the dataset pairs realistic clutter with scale so agents can train on rich, simulatable homes. The left panels illustrate dense layouts and varied region types, which means scenes include many small items and complex object relations. The center collage highlights diverse floor plans. The right panels emphasize object variety and abundance, and the bottom row shows two applications, layout generation and embodied navigation. So Table 1 compares indoor scene resources and shows that this dataset pairs high scale with realistic density. The table reports scene counts, region and object types, average objects per region, the number of CAD models, and whether physical optimization is applied, which means collisions are resolved through physics simulation. The last row highlights 40,000 scenes with 288 object types and 41.5 objects per region. Competing sources either lack small item density or skip physics consistency. So Figure 2 lays out how the team turns messy real scans into clean, sim-ready scenes that keep dense clutter. The left panels show region pre-processing and asset labeling, where a vision language model checks mapped categories, and a canonical pose means fixing an object's forward direction for consistent placement. The middle illustrates retrieving matched assets to replicate the scanned layout. The right stack shows optimization rules and physics simulation, which resolve ground alignment and collisions so scenes remain stable. So Table 2 reports how 3 layout generators handle cluttered versus simplified scenes. The key message is that scores get worse on the full data with many small items, which means dense object distributions remain hard. Frichet inception distance measures visual realism from rendered top views, so lower values indicate closer to real scenes. Physics-guided phi scene leads on the full set, especially in living regions, suggesting physical constraints help models place objects plausibly. Alright, 2 takeaways stand out. The dataset couples scale with real clutter, keeping small items in physics consistency so models face the messiness of actual homes, and the pipelines make scans simulatable and interactive, which unlocks tougher, more useful training for generation and navigation. Thanks for tuning in. I am Alex. This was the AI Research Roundup.